Welcome to length contraction. We saw previously that for a moving observer, time changes. It changes relative to a stationary observer. And here's how we calculate the difference. Here is the time measured for an observer in the usual way. We can then convert that for an observer that is moving using this equation. And this difference occurs because the velocity of light depends on the distance divided by the time. And this value must be constant, and therefore the time and the distance change to keep that true. And this equation is how we measure the difference in time for a moving object. If we're trying to measure the length of something that's moving, we have a similar problem. When trying to measure the length of a moving object, the observer who is riding on that object is regarded as being stationary relative to it. We know, though, that because they are moving, they're experiencing time differently. Their time is longer than for this observer over here. So when they are trying to calculate the length of the train, they are going to be multiplying the velocity that it's travelling at by the longer time, which means that they end up with a longer length, even though they are the stationary observer. For this observer over here, we know that their time is going to be shorter. So when they are calculating the length by observing how it passes a point, they're going to be multiplying the velocity by the time that they have recorded, that time being a shorter distance and resulting in a shorter length. Here is the length contraction equation. Here we have the length for a moving observer, and here we have the length for a stationary observer. We can analyse these equations together. This expression will always be less than or equal to 1, and therefore the numerators will always be less than the denominators. So the time measured by a moving observer will always be greater than for a stationary observer, and the length measured by a stationary observer will always be greater than for a moving observer. Time dilates with movement, and length contracts.